Hey you guys, alright. In this video I'm going to be going over a couple of examples from this worksheet. I know that some of you guys are going to be working online, and so you're going to be looking at a screen that looks like this, and some of you guys have this worksheet hard copy. So you're looking at something like what you see over here on the right. So what I'm going to do is I'm going to show work over here on this side, but if you notice, the questions are the same from over here to over here. Alright? Okay, so the first section says determine whether the solid is a polyhedron. If it is, name the polyhedron. Okay, now if you remember, a polyhedron has faces, edges, and vertices, and basically all the sides are more or less straight. Over here, some of these are curvy. And actually all three of these examples are in your notes. This one is a prism. So it is in fact a polyhedron. So yes. You could write prism, or if you want to be more specific, you could write rectangular prism. Alright. This one is not a polyhedron. Okay? If you look at your notes, I actually use a cylinder as an example of what is not of something that is not a polyhedron. Okay? So this one's no. I'll let you guys figure out what number 3 is. In the second section, they ask you to use Euler's theorem, which is in your notes on the same page as this stuff. Okay? If you don't remember, Euler's theorem says that the faces plus the vertices equals the edges plus 2 within any polyhedron. Okay? So for example, over here it says the faces are unknown. The vertices there are 4 of them. There are 6 edges. So I have plugged in these numbers, these values, into this equation over here. N plus 4 stays the same. 6 plus 2 is 8. If I subtract 4 from both sides, N equals 4. Okay? You do the same thing as for numbers 5 and 6. Okay, this section you skip. Before I forget, let me go ahead and mark these answers over here. So number 1 is yes, number 2 is no. You guys can figure out what number 3 is. For number 4, what is N? N is 4. There you go. 5 and 6, you guys can figure that one out. Alright, you go down here to number 10. Number 10 corresponds with number 7 over here. It says find the number of faces, vertices, and edges of the polyhedron. Okay, so faces, there's 1, 2, 3, 4, 5. Vertices, 1, 2, 3, 4, 5. Edges, 1, 2, 3, 4, 5, 6, 7, 8. Okay? And the faces plus the vertices, which is 10, has to equal the edges plus 2. 10 does in fact equal 8 plus 2. So we're good. Now, over here, how many faces does the figure have? 5. How many vertices? 5. How many edges? 8. Notice that the numbers over here do not line up with the numbers over here, because over here I had you guys skip a few, and over here you can only have one answer per problem. That's the reason. So I imagine most of you guys aren't going to have this problem because you will either have this worksheet or you'll be working online. You probably won't have both. Alright, so that's how you do this section. I'll let you guys figure out the rest. Alright, and oh, I forgot to mention you guys are skipping number 16 also. So don't do that one. Alright, so after this section, We're going to go on to the back. This section says, determine whether the solid is convex or concave. Alright? Now, if you guys remember, concave, it looks like the figure is caving in at some places. Convex, all the vertices will be pointing out. Okay? So this one, as you can see, some of the edges are cutting in, so this one is obviously concave. And over here, this corresponds with number 25. Okay? I'll let you guys figure out these two problems over here in this section. Alright, in the next section, it says, describe the cross-section formed by the intersection of the plane and the solid. On number 20, this is where the plane intersects the solid. If you count the sides, there are 5 sides, so this is a pentagon. Okay? And this one corresponds with number 28. There we go. Alright. Number 23. Assume at least one face of a solid is congruent to at least one face of another solid. Which two solids can be adjoined by congruent faces to form a hexahedron? Okay, you probably noticed that I skipped number 21 and number 22. I'm going to leave those two for you guys to figure out. For number 23, you need to know what a hexahedron is. Okay. It's not a hexagonal prism. A hexahedron is going to have 6 sides. Okay? Now, if you are really good at visualizing, that's great. I recommend that you read each of the answers carefully and visualize what it's talking about. If not, it really does help to draw it out. Okay? Take a look at A, for example. A rectangular prism and a rectangular pyramid. Alright. Suppose I'll make a rectangular prism over here. It's probably going to look very cube-shaped. Yours doesn't have to. There we go. Now I'm going to attach it to a rectangular pyramid. There we go. That doesn't really look like a hexahedron. Alright, so that's not it. A triangular pyramid and a triangular pyramid. Alright, so triangular pyramid is going to have a triangular base. Okay, and then it's going to attach to another one. My drawing is really crude, but if you think about it, if you imagine a triangular pyramid attached to another triangular pyramid, each triangular pyramid has 3 sides, so together they're going to have 6 sides, which is what you're looking for in a hexahedron. So that's the answer. And this corresponds with there we go. Number 31 here. Okay. Okay. And you guys can go ahead and skip number 24. Alright, last section. You're skipping number 26. You're just doing these two. I'm going to do number 25, and I'm going to leave number 27 for you guys to do. It says, what type of triangle is the shape of the cross-section? Alright, we already went over cross-sections. As you can see, the plane is intersecting here. Gosh, here, hold on. Sometimes this tablet's kind of difficult to manipulate. There we go. Alright. You can kind of see that this is an equilateral triangle. But even if you can't, if you imagine a cube, which is what this is, the diagonals of the cube are all going to be congruent. And each of these sides are diagonals. Okay? So, this is going to be an equilateral triangle. Okay. And over here. There you go. And I will let you guys figure out the last one. Alright? That's all.